The process of balancing redox equations is not difficult, and I mean that. It is tedious. It's multi-step. So it takes time, it takes effort, it takes knowing the pattern after you do enough of these problems. We're going to learn this process in this video. There are not going to be that many reactions on the exam for this topic or questions. Nevertheless, it's an important skill that you are expected to learn. So let's begin right away. We will talk about acidic reactions only. Basic reactions are not explored. We may discuss them when we meet. The rules, as I said to you, are multi-step you have, and let's begin. You'll always be given a reaction like this, where you will be asked to balance it. The first two rules are what we have done so far. Assign oxidation numbers and divide the reaction into two incomplete half reactions. So let's begin. Now, permanganate, for the sake of time, permanganate, if you do this on the side, where you have manganese minus, you set this equal to -1, that's the overall, 4 oxygens minus 2 each, and X. When you solve for manganese, in this case, X minus 8 equal -1, it's going to come out to be +7. So what we do right away is we take those charges, +7, put that on the top. Oxygen is a -2. Nickel, in this case, it's a 0. It's an element. It's an element. Manganese +2 is a +2. And nickel is a +2. Again, those are ions, monatomic ions. This is an element. And of course, we solved this as we did before. Now, let's talk about the next step, which is dividing the reaction into two half reactions. Let's delete this really quick. So here's how we divide it. Take permanganate. It's a common oxidizing agent. Draw the arrow. And again, put whatever contains manganese on the other side. And in this case, it's just manganese atom. And of course, we take nickel and nickel +2 on the other side. Now, we said that this went from a +7 to a +2. Here's the 2. Do you know what that is? What happens when the oxidation number goes down? So that would be reduction. And of course, we went from 0 to a +2. So the oxidation number went up. So that would be oxidation. Now, step 3 is new, entirely new, and it's the most important step. So you are to do this in this order and this order only. You cannot jump around. First step, A, and notice how I'm going to apply it as I go. It says balance all elements other than O and H. So here's A. O other than O and H. So elements other than O. So here in this case, we have manganese. There's one atom. And of course, there's also one atom on the other side. So there's no need to balance. It's a 1 and a 1. One manganese atom, one manganese atom. So we're going to use an acronym for this. We're going to say, we're going to use at for atoms. Nickel in this case, you have one nickel, one nickel. So there's no need to add anything. If there was two nickels here, then you'd have to put a coefficient on the other side. B, balance O by adding H2O. Very well. So in this case, let's count how many oxygens we have on this side. It says we have four oxygens. So the question is, how many water molecules do we have to add? Now, before I add this, let's on the side here understand what this means. So let's look at water as a molecule. If you were to draw it, it would look this way. We'll learn about drawing later. How many oxygen atoms do you have per water molecule? How many? One. So you only have one oxygen atom. And of course, you have two H's. But you only have one oxygen atom. So for every oxygen atom you add, for every water molecule you add one oxygen atom. So again, the ratio of H2O to O is a 1-to-1. There's only one oxygen atom in the water molecule. So for every oxygen atom you need to add one water molecule. So in this case, we have four. Then we must add four water molecules. Here, we don't have anything in terms of oxygens, so it continues. So of course, this is an easier one. No need to add any oxygens because there are no oxygens on either side. C. And by the way, for the next one, we're going to say O. C is balance H by adding H plus. So in this case, and we need more space for this. For this case, we have four oxygens, and then we have hydrogens on this side. So we have to be aware of that. Let's see. 4 times 2 is 8. You have 8 hydrogen atoms on this side. So how many H plus ions should you add on this side? You answered it correctly. It's 8. So you would add 8 H plus. Once again, we had 8. 4 times 2 is 8. Now we have 8, and we add H plus ions. It's acidic. That's what an acid is, if you recall in the last lecture. On this side, of course, we don't have to add anything because there is no H's on either side. So there are reactions that, one half is easy to do, but you have to be careful. Some require both, like in the next problem. And finally, for this is D. And by the way, if this is H, charges. So pay attention to this one. In this case, we have 8 H plus MnO4 minus, I'm going to put these in circles so we can see them, and then a plus 2. And on this side, we have a 0 and a plus 2. So pay attention to this. I'm going to take another page here to do this on the other side because I need to show you some visuals. So Let's do one at a time and pay attention to this. So it says 8 H plus MnO4 minus equals manganese plus 2 or 2 plus 4H2O. This was what we had before. Here it is. 8H plus. And we'll get back to this a little bit later, but for now, let's work on one at a time. What do I mean by the charge? I mean by the charge is what is the total charge on each side? So you have to look at charges on the top. Remember that from naming and ions. Here, what this tells us is that we have 8 hydrogen ions, each carrying a positive charge. So I'm going to draw them out. And I'm going to use blue for the positive charge. We also have 1 permanganate with a negative charge. I'll use a different color. So let's begin. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1, and plus 1. So that's my 8 positive charges. This one has a negative charge. It's a negative 1 right there. Okay, before we move on, let's check the overall charge. Well, we have 8 positives and 1 negative. So what is the total? Well, you can think of it this way. 1 positive cancels out the negative. And now you're left with 1, 2, 3, 4, 5, 6, 7. So this side has a plus 7 charge right there. Now let's look at the other side. The other side has a positive 2. No need for me to, but I can draw it right there. So there's just a positive 2 positives. What this one is telling you, this rule, let's go back to the rule really quick. It says balance charges by adding electrons. So we're going to give this the acronym C for as part of the acronym. So it's by adding electrons. You're neutralizing, or you're making balancing it by adding negative charges rather than positives. I know you're used to positives because it's intuitive, but we're doing negatives. So the question is, how do I go from positive 7 to positive 2? Just think about subtraction. How do you go from 7 to 2? You have to minus 5, right? That's what it is. So you would add 5 electrons. So 7 minus 5 is plus 2. And remember, we say minus because the electron is negatively charged. So here's what I'm going to do. I'm going to put the E minus E, 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 and E. And now watch. I'm going to cancel out. This really helps me to see it, not just you guys. So this one cancels out that one. This one cancels out that one. This one cancels out this one. This one cancels out that one. This one cancels out that one. And what are you left with? 2 positive charges. This one has 2 positive charges. That's why I added 5 electrons. Remember, we're adding electrons because we're in oxidation reduction reactions. So repeat this video however many times you want, but that's what I did here, is I had to add 5 electrons to get a positive 2. Remember, we're balancing with electrons because that's what's being transferred. can't just put positives. So this case, we had 5 electrons plus 8 hydrogens plus manganese, permanganate equal Mn plus 2 plus 4H2O. Great. And now D for this one, we don't have to go to another page, but think about it. You have a 0 and you have a plus 2. You're adding electrons. How do you go from a plus 2 to a 0? You have to subtract the 2. So that means you add 2 electrons. Once again, I understand the intuition here for you, but remember, we're in science. A lot of things can be counterintuitive, especially when we get to quantum mechanics. But here it is. So that's a 0, that's a plus 2. They cancel out. Generally, this is the part that students struggle with at first, but again, with practice, you will get good at it. Finally, we're getting really close. If electrons in one half reactions do not balance those in the other half reaction, multiply each half reaction to get the least common multiple. Well, we need electrons to remember. Let's go back to the very first page. We said the number of electrons in the reaction does not change. So we have a problem now. We have 5 were gained somehow, because that's the reduction, and 2 were lost. Where's the difference? What happened? So that's why we need to make the number of electrons equal. And to do that, it's from math. What's the least common multiple between 5 and 2? It's 10. So that means you have to multiply this side by 2 and multiply this one by 5. Once again, 5 and 2 have a least common multiple of 10. So I'm going to drag this down. And then we will multiply this whole thing by 2. We will multiply this one by 5, but we'll do that in the next step. So let's multiply. 2 times 5 is 10 electrons. 2 times 8 is 16 hydrogen ions. 2 times permanganate is just 2 permanganate ions. 2 times manganese ions is 2 manganese ions. And 2 times 4 hydrogen is 8, water, is 8 water molecules. Now I'm going to multiply this by 5 right there so that we can do it all nice and easy here. 5 times 1 nickel atom is 5 nickel atoms. Five nickel ions, and that's 10 electrons. 5 times 2 is 10 electrons. Remember, in math, we have to multiply the whole equation. We can't just multiply one variable. Very well. So we have our half reactions ready for the last or close to the last step. I know. Just this is science. So let's talk about the next one. It says add the two half reactions and eliminate any excess electrons, protons, H plus, OH minus ions, water molecules, etc. And then, of course, we're not doing in the next steps, we're not doing it in base, so we can jump to 8 after 5. So here, the whole point is now the electrons have been transferred. So what needs to be done is that they need to cancel out. So when they're on opposite sides, you subtract them. 10 minus 10 is 0. So you cancel them out. If there were hydrogens on opposite sides, you have to also cancel them out. If there were waters on opposite sides, you have to cancel them out. So in this case, we have nothing else. And all we have to do now is combine them, combine the two reactions. So I'm going to erase the electrons because I canceled them out. And now all I have to do is combine them. Now, I wrote this in a way that might be deceiving here. So for that reason, I'm going to move this next here. Now, what you're doing is you're adding products to products and reactants to reactants. You cannot add all over, right? So you have 5 nickel equals 5 nickel plus 2. Okay, so now what I'm doing is I'm adding all of the reactants and all of the products. So it doesn't matter what order you do it. So you can do this and then that. So it says 16H plus 2MnO4 minus plus 5Ni equal 2Mn plus 2, 8H2O, and F5 Ni plus 2. Okay, I gotta make this a little bit more visible here. Let me just shrink them here so we can show the nickel. Very well. Finally, you have to check the number of atoms and the charges. 16 hydrogens, 8 times 2 is 16. 2 manganese atoms, 2 manganese atoms. 2 times 4 is 8 oxygen atoms. Here we go, 8 times 1 in oxygen, that's 8. And then 5 nickel is 5 nickel atoms. Finally, the charges, we have 16 positive charges. 16 times positive 1 is plus 16. 2 negative charges. Let me put this in. So minus 2. That gives us a plus 14. On this side, we have 2 times positive 2. So that's a plus 4. And 5 times positive 2. That's a 10, which is also plus 14. Voila. That tells us that it's finally balanced. Yes, I realize it's a step, but as I was a student like you, at first it was scary. But again, with just some practice and going over them, do enough of these, watch more videos online on the Khan Academy. We'll do more when we come to Wednesday, but try to attempt it at least. At least attempt it. So commit to doing it. Because again, without, in this case, committing to doing it, you will never start. So leave you there. Work on this one. At least if you get halfway through somewhere, it's better than not starting.